Question 17. Histogram below shows the information about the ages of passengers travelling on a plane. We're told that no one is more than 80 years old, and we are given that there are 24 passengers on the plane aged between 40 and 60 years old, which means that the area of this section of our histogram is 24. So we're going to start by just doodling that piece of information down, the fact that the area of this is 24. And we're being asked to work out the total number of passengers on the plane, which is basically the combined area of every single one of these bars. Now, in order to find the area of any of these bars, we're going to need to know what the scale is for our frequency density, and that's where this comes in. For each one of these small markings up the side, we can label them all as X. It doesn't technically matter what you make as your variable here. I could technically call this X and 2X and 3X, but generally speaking, if you want to avoid fractions as much as possible, I always make the smallest value X. So the tiny little squares are each X in height, and then the darker ones that occur every 5 are multiples of 5X. So from that 24 is the area of a rectangle. That rectangle has a base of 20 and has a height of 6x. So if we look at this really close here, this is where the 5x is, making this 6x. So we have 20 times 6x equals 24. We then simplify and solve this equation. So we get 120x on the right hand side, and then when we divide both sides by x, we end up with 0.2. So each of these little increments is a 0.2, which makes 5 of them 1, which is 5 times as big. So basically it's going up in ones after every one of these dark marks, or every 5 mini steps. From there we then just need to find the area of all of the other bars and then add everything together, including this 24. So this first bar here, we have 10 across and 0.2 high. Multiply them together will give us 2. This bar here, we have 10 across and 1.8 high, giving us an area of 18. For this bar here, we have 5 across, because this marking here is 25. 5 across, followed by a 6.4. So 5 times 6.4, which will give us 32. We have this bar here, which is 15 wide and 2 tall, so an area of 30 people there. 24 for the pink section, and then for this section we have 20 as our width and a 0.8 as our height, which will give us 16. So the total number of passengers on this plane is going to be 2 plus 18 plus 32 plus 30 plus 24 plus 16. And that's going to give us 124 passengers in total. For the next part, a passenger on this plane is picked at random. Work out an estimate for the probability that this person is older than 55 years. So from our original graph, we are interested in everything to the right of this blue line, because that blue line represents someone who is 55 years old. So all of this to the right, the area of all of this is going to be the number of people that are older than 55. So first of all, this number of people that are going to be older than 55. We have all of the last bar, which was 16 people. And we're going to have a quarter, because we have a quarter of this bar, a quarter of 24, which is going to be 6. So we'll end up with 16 plus 6 for 22 people in total. So that is the number of people who are over 50 out of, because it's a probability, out of the 124 that we start. So 22 over 124 would be our final answer. If you simplified that to 11 over 62, you are not wrong. And if you happen to do that as a decimal and end up with 0.1774, so on and so forth, you would also be right.